Hello friends, so today we are going to see more questions which came in GATE 2014 paper. Okay, so these questions comprises now I as already stated in the previous video that from that video we are going to see the 2 marks question. So this question consists of 2 marks. Okay, so this question number 31 is of mechanics subject. As you can see, this is a very common question. A mass 10 kg is initially at stationary on 45-degree inclined plane as shown in the figure. The coefficient of dynamic friction between the body and the plane is given as 0.5. The body slides down and attains a velocity. The distance traveled by the body along the plane is. Okay, so as we know, the body is at rest and it attains a velocity of 20 meter per second. Since actually you have to draw the free body diagram. Okay, unless and until it is not mentioned that the body is at attains a uniform velocity, you cannot take acceleration as 0. You have to consider the acceleration. So the body will start sliding down. Okay, so here is the free body diagram. This is the normal reaction. This is the frictional force in the backward directions as the frictional force opposes the motion. These are the components of mg. Okay, so you can write the Newton's second law. Okay, in this direction. So mg sine 45 minus mu rn is equals to ma. Okay, and rn is equals to mg cos 45. Since there is no moment in perpendicular in the direction perpendicular to the inclined plane, so we can take acceleration as 0. So rn is equals to mg cos 45. So from here you will get the acceleration, and after that, since we know this equation, v square is equals to u square plus is equals to 2s, so we can easily get s. S is the distance between the starting point and the end of the inclined plane, so you will get 57.8 meter. Okay, the next question. This is the question from strength of material. It's a very direct question and no tricks are available here. No tricks are required here. So we know we have to consider a simply supported beam of length 50h, rectangular cross section of depth h and width 2h. The beam carries a vertical load at the midpoint. The ratio of maximum shear to the maximum bending stress we need to find out. Okay, so we know in case of a rectangular cross section, shear stress is maximum. What is the value of maximum shear stress? 3/2 of average shear stress. Okay, so this is the value of maximum shear stress, 3p by 4h square, and we know sigma by y is equals to m by I. Sigma is the bending stress, so m is the bending moment. Bending moment is p into l by 2, and since it is simply supported beam, so bending moment will be at the mid of the length of the beam. Okay, so p into l by 2, l is 50h. Okay, and b dq by tel d is means depth is h, sorry, breadth, width is 2h and depth is h. So substitute the value, you will easily get 75 p by h square. Please don't do it in a hurry, do it in a very easily way and in a very neat and clean way, so that there won't be any confusion. Okay, so shear by bending stress we have to find out. Actually it is maximum shear by maximum bending stress, so you will get 0.1. Okay, so this is the answer. Now the next question, you have to find out the damping ratio, okay, of a single degree of freedom spring mart damper system. So we know the damping ratio formula is C by Cc, where C is the damping constant and Cc is 2 root over km. It is called critical damping. Okay, so C, we know damping constant is 25 Newton second per meter. Please be careful regarding the units. As the question looks simple, you should be more and more careful. Okay, no need to make any mistakes. Now this is the 34th question. An annular disc has mass m and radius r and outside r. Annular disc is a ring like structure. Okay, the disc rolls on a flat surface without slipping. Okay, so if the velocity of the center of mass is v, the kinetic energy of the disc is. Since the disc is rolling is a motion which consists of translational plus rotation, so you will have to consider two types of kinetic energy: rotational kinetic energy and translational kinetic energy, and you have to add the both. So we know what is the rotational kinetic energy and translational kinetic energy is half mv square, where v is the velocity of center of mass. Okay, and in case of rotational kinetic energy, we know half I omega square, where I is the mass moment of inertia about the rotating axis. So if you will suppose the whole annular disk is rotating about the center of mass, plus if you will give that axis velocity v, so you will see the rolling motion. Okay, so here half m to we know that the annular, this is an annular disk, so you have to find out the moment of inertia in this way: half m into 2r whole square minus half mr square. You will get 3 by 2 mr square. Okay, so kinetic energy of rotation is half I omega square, half 3, which is equals to half into 3 by 2 mr square into omega square. Omega, yeah, everything is okay. So now we know which is omega into r, where means where the velocity, where the radius is here 2r, so this will become v, the velocity. Okay, so 3 by 16 half mv plus half mv square, you will get 11 by 16 mv square. So this is the quite of basic questions. So if you are having any confusion, please revise your basics. Okay students, and the rest of the questions, the next few questions I'm going to discuss in the further video. If you guys have any doubt, just revise your concepts, see the NPTEL videos, they are very helpful, and have an awesome day. Okay, bye.